Alright, so this is a common mistake students make is they often will do wrong things with logarithms. And so this one's kind of going through an example of determining stuff that was done right or stuff that was done wrong. And all of these I chose bases that you can plug into your calculator. Alright, so the first example is the log of 10 divided by the log of 5 the same as the log of 2. And the answer to that is no, that's false. If you type the log of 2 into your calculator, that comes out 0.301. If you type in the log base 10 of log base 5 into the calculator, that comes out 1.4301. Those are not the same, and so that's false. Right, that's a common mistake students will make. The second example, log of 10 minus the log of 5 equals the log of 2. Well, that's one of my properties. Alright, this was solved using the property. I can rewrite that as the log of 10 divided by 5, which equals the log of 2. And so that's true. And if you type in both sides of that as is without using the rule, it comes out to the same value. If you take the log of 10 minus the log of 5, it comes out to that 0.301, which is equal to the log of 2. Alright, and that's the true case. The second example, log of 20. Natural log of 20 is equal to the natural log of 4 plus the natural log of 5. That's true. Natural log of 20, well, 20 can be rewritten as 4 times 5, which then you use your property natural log of 4 plus natural log of 5. If you type both of those in, it'll come out the exact same value. That's true. Common mistake students will make is the following. Well, I know 20 is 4 times 5, and they'll write natural log of 4 times the natural log of 5. But that's false. If you type that in, if you take the natural log of 20, it comes out 2.9957. If you type the natural log of 4 times the natural log of 5, that comes out 2.231. Well, now they're close, just because the numbers come out close, but they're not the same, right? 2.9 is very different than 2.2. Alright, natural log, so kind of notice where the parentheses are here. ln of 5 squared equals the ln of 25. And so the parentheses are over, so this really means the natural log of 5 times the natural log of 5, right, if I'm squared. Well, that's false. That's not true. If you take the natural log of 5 and square it, it's not the same as the 25. That's a false statement. But what we can do, if I take 2 times the natural log of 5, well, I can move that 2 in. So then it's the natural log of 5 squared. The squared is inside the natural log, not outside the natural log. That does equal the natural log of 25. And you check that out. Take 2 times the natural log of 5. That comes out 3.2188. It's exactly the same as the natural log of 25, which comes out 3.2188. All right, those are exactly the same. That's true. Right, next example. Log of 20 plus log of 10 equals log of 30. Right. Again, students will want to do this. This is false. If you type in log of 20 plus log of 10, comes out 2.301. If you type out log of 30 comes out 1.477. Those are not the same. That is not true. What is true, log of 20 plus log of 10 equals log of 200, because the log rule is when I add, I multiply when I pair them together. And so if you type in log of 200, log of 200 does come out to 2.301, which is true in that case. Alright, log base 3 of 9 is equal to log of 9 divided by log of 3. That's true. That's the change of base formula. Log base 3 of 9 is equal to the natural log of 9 divided by the natural log of 3, which is equal to my previous expression. Also true, because that's the change of base formula. Log of 3 of 9 is equal to the natural log of 9 divided by 3. That is false. Alright? This expression is not the same as that expression. If you take the natural log of 9 divided by the natural log of 3, it is not the same as ln of 9 divided by ln of 3 is not the same as the natural log of 9 divided by 3. Alright, so that's false. Sorry, I had to pause that. I got a phone call. I didn't feel like starting my video over again. So natural log, if you type these out in the calculator, they come out to the very different answer, alright? So the part C is false. First two are true. They're equivalent. If you type in the first two statements, they're the same. That's the change of base formula. Those are the equal. The last statement, however, is false. Alright, and if you type these out in the calculator, you'll get two different answers. But again, students want to do that. So it's sort of a common mistake students make with logarithms. Same things about the next one. Next one's also common mistakes. The natural log of 20 minus 5 is the same as natural log of 20 divided by natural log of 5. No, that's false. Natural log of 20 minus 5 is the natural log of 15, which does not equal the natural log of 20 over the natural log of 5. That's false. If you type those in, you'll get two very different answers. Second statement, however, is true. If I take the natural log of 20 divided by the natural log of 5, it's the same as the natural log of 20, and so that's the true case. That's my rule. The next one is false. This is the biggest mistake students typically make with logarithms. They think they can write it this way, but that's not true. It's got to be division inside my logarithm. If it's division outside my logarithm, that's really a change of base formula, and so this is false. If you typed it in your calculator, you'll find that those two expressions are not the same. Natural log of 20 divided by natural log of 5 is not the same as natural log of 20 minus the natural log of 5. Alright, the last one. Natural log of 9 is equal to, not the natural log base 10 of 9, is the same as 1/2 log base 81. That's actually true, because I can rewrite this, right? This rewrites as 81 raised to the 1/2 power, which is the square root function, square root of 81, which is 9. So that's true. This is also true, right? Same idea. I can move the 2 inside. I get log of 9 equals log of 3 squared. Log of 3 squared is the same as log of 9. And so both of them, my last statements, both of them come out true. If you typed them in, right, they're both true. So that's some examples of kind of testing out the rules, making sure you kind of recognize the rules, and sort of pointing out common mistakes students will do with logarithms. Alright, so we'll stop there. We'll get into using laws of logarithms to expand and compress